Hi, I'm Ben, the production manager of Syvecs Limited, and today we're going to be talking about soldering. Soldering is a subject that has been apparent in at least my life for the last 10 years, and I mean I started at it, I was not good at all. It takes a lot of practice and learning from your mistakes, and scenarios will, certain scenarios will teach you things that you didn't necessarily think that you would approach in that particular way. So we're going to go through a few examples here of, this is an S6i board. Yes, it is. It's an S6i board. It's quite a common board that we use. And there are several soldering techniques involved with this board that vary from one to another. And you wouldn't normally think that soldering, okay, you know, it's just soldering. Soldering isn't just soldering. To be able to do it properly and be proficient at it, you kind of need some decent experience and, least of all, a decent soldering iron. So we're going to go over the equipment that we use here, and I'm going to talk you through how we approach certain soldering techniques, what you should be doing with what sort of temperatures, and what type of solder we use as well. So onto that. We predominantly use Kaisertech and their JBC range of soldering irons, or desoldering irons, as this example shows, is they're amazing. Arguably one of the best pieces of kit I've used in the last 10 years. This one, you know, myself, I do a range of different soldering methods in-house. You know, if we have problems with certain headers or someone, you know, burns one out or something, we're obviously going to have to use a desoldering iron here, that's the pump there, the controller, and that's the actual desoldering iron itself. Not the sort of thing a hobbyist would need, I'll be honest. You can get these pretty cheap, or cheaper versions that will do a good enough job online for around, I think, about £100, something like that. This one, I can't remember how much it is. It's not particularly cheap, I'll be honest. And then we move over to the soldering stations. So these also shut off. I'm going to pull one of these forward. These have hot swap tips, which are great. If you're on the fly, anybody that's used a soldering iron for long enough will know that changing a tip on a soldering iron is a headache, because you have to wait for it to cool down, and you, in essence, cool down, unscrew it, which is a normal soldering head type, and then you have to change the tip, put it back on, plug it back in. It can be somewhere up to, you know, 15-20 minutes, depending on how much you want to burn yourself. These ones are great. So as you can see, it's hot swap as well. Use this one. So we pop it in there, pull it out. Now it's been removed, and it, you know, to put it back in is exactly the same. So bang, done. And this is this has a sensor built into the holder, or the housing, whatever you want to call it. So once you pop this back in, it will actually put it at a sleeping temperature, so you don't burn the tip out, which is quite a common problem. And these, I mean, these are about 12 to 16 pounds, and they'll last us up to a year because of this. So anybody that knows soldering irons will know that burning out tips is commonplace, and it can be quite expensive, especially on the gas types. So, right, I'm going to also show you the extraction we use, which, if you're using lead-based solder, is important. It's going to run through the solder type we use and size, because this is a common error that I see occur. And when I first started to learn how to use solder, or solder in general, I was taught wrong. So it's best to know what you should be working with, rather than what you shouldn't be working with. And in most cases, from what I've seen, is what people are using what they shouldn't be working with. So this is what we use. We use two solder sizes. They're both the same type. They are lead-based and silver-based, hence we use extraction. The reason we use lead is this. The people out there are going to know that have had some experience with solder, that lead-based solder just has much nicer properties. It's easier to work with. It reflows very well, The silver content also helps with, you know, the finish of it. I don't know the absolute ins and outs with solder, but what I do know is that using, you know, lead base with silver and your sizing is paramount, in my opinion. I was taught years ago to use 1.5 mil, which is absolutely massive. And when you're, obviously we're talking about a board level here, you don't need this. I mean, even if you're looking at soldering wire, and I recommend you don't, because we watch one of our previous videos on some crimping, soldering is not ideal. I mean, it's circumstantial. If it's all you can do at the time, I mean, it is what it is. You do what you do. The solder doesn't need to be massive. There's two drawbacks to using big solder. One is that you suck the energy out of the tip of the soldering iron, obviously measured in watts, and you expense a lot of the energy produced by the soldering iron to be able to physically melt it. At that point, you're starting to lose your headroom for being able to heat up the surface of the board, and then you start to get a messy solder. So I'm going to show you what that looks like by reducing the temperature of our soldering iron in a moment, and we'll go over that in a moment. So the sizing we use, for anyone that would like to know, is 0.7 millimeter and 0.46 millimeter, which is very small, but is good soldering for this borderline, in my opinion, micro soldering solder. You want to go much smaller than this if you're soldering any components on the board, but I get away with this with a smaller tip. This is the Weller extraction system that we have here. It's the Smog 4V. It's a decent bit of kit. You can run up to 4 bench extraction pipes. We currently have 2 installed. We've got another 2 to put in. You can turn them off at the valve, which is at the back here, which will increase flow. Obviously more of them are turned off and there's only one, you have the full flow running through there, or extraction, and then you have all of them on. I mean, even with all of them on, it's still really good, as you'll see in a minute when I start showing you some different soldering. So yeah, that's it's got a decent reach on it. So when you're working, you're going to want to put this, you know, somewhere within range of it. I mean, the direction is not really going to matter, providing you can work still, as well as, you know, have the solder smoke go straight up the extraction. So we're going to go ahead and show you some examples here. Before we do that, I'm just going to explain the different areas here and techniques that are involved with soldering these boards. Mostly around this board, they are relatively straightforward. You need something in the range of between 185 to 240 degrees Celsius to work on for the best part of this board, probably 90% of it. The problem lies with this area here. It has a number of MOSFETs on it, microchips, capacitors, resistors, all connected to these 2 particular solder bridges here, also up here, which they're missing on this particular kit because it's an eye. And they absorb an enormous amount of heat. Anyone that understands circuitry will understand just how much energy a MOSFET can absorb, and it will pull it to the ground plane on the board, or obviously the 12-volt plane as well, because they switch both sides. So the wattage needed is very high. So I would normally solder those at approximately 300 to 320 degrees. So we're going to move on with the soldering. I was going to go and attempt to reduce the temperature far enough to be able to solder and make a mess of it, but it's not letting me go below 200 because it seems that these guys know what they're doing. So what I'm going to do is I'm going to use the largest solder at the lowest temperature, which is 200 degrees, which I mean is fair enough. The melting temperature this from memory is 185. So if I get a pad that's big enough, it will cause me a few problems. So let's go with this one so you guys can see. So as I was explaining earlier, this is part of the H-bridge set. This particular one was modified a while ago for a particular car. It's, you know, this isn't normal, so just it's not worth going over that. So this is part of the H-bridge set. So you have high and low, which I was saying earlier have very large planes within the board, and I'm going to solder here, and hopefully this is going to give me some grief. It seems it is. No, it's not. Oh no, it is. So once I attempt to move away from this, it will start to cool down rapidly. So there's not enough heat that's been pushed into this pad. As you can see there, it's almost solid. It's not wanting to do anything. I mean, you can get around this if you really try. Nah, it's not having any of it. I mean, even I can't get that to go over there. So, right, now let's retry that with the right solder size on the next pad and the temperature where it should be. Right, so now I'm going to pop this up to, this was 200 degrees, I'm going to pop this up to, let's say 220, which should be borderline enough. And I tend to have a little bit too much, it's at 225, okay. So now, what you're aiming to do here, as I was doing here, and I'm going to explain it a bit more, is that you want to tin, it's known as tinning the tip of your soldering iron. So you can see there, the solder is taken to the tip of the soldering iron. Now, once you do that, you want to build up enough solder so that it makes contact with the pad. And it is, and I don't think this is quite hot enough. No, it's not. Let's go up a bit more. Let's try 260. Let's say I normally solder at much higher temperatures because I tend to just blitz through this, and I'll show you in a little bit. Here we go. Now that's taken to the pad very nicely. If you have a very large plane on either of these pads, one technique is to solder both pads, and then what you're going to do is you're going to feed solder into the tip of the iron and the ball of solder beneath it, and then as you're feeding, you're going to swipe across and you create a bridge known as a solder bridge. There we go. I mean, that one's not perfectly neat. I'm doing it at a bit of an angle, but that's essentially what you should be looking at there. So the bottom one there is a bad one, or bad example, not enough temperature and the solder being too large, and the top one is, in my opinion, just passable. Right, I'm going to pop the extraction on because I'm going to do a fast run and show you what you can actually do when this is set to the right temperature. I normally run about approximately 280 to 300 degrees for the most part. So I'm just going to do a speed run here and show you just how easy it is. Once you get your settings correct, you should be able to do a speed run just like this, really. So you're feeding. And a lot of the consistency in each of the solder is muscle memory. I couldn't tell you how much I'm feeding in here. It's just more of a practice makes perfect situation. And there you go. That's how your solder bridges should look. People have lots of different techniques with soldering. I mean, there's people that will do it completely different to me. Left and right handedness is also a factor in how you solder. Your environment that you're in, whether you're using gas soldering irons, whether you're using plug-ins. I'm not sure that you can get battery ones. I could be wrong. But essentially, it's practice. Please don't settle for it's going to work or that will do, or it's not going to help you. Like, soldering is one of those things that if you get it wrong, it could cause numerous issues. It can cause, again, like I've been through this in previous videos, misfires. You could have problems with power supplies. You could have grounding issues, which is very common. And if you're using wire for any given point that you'd want to really be focusing on butt connectors, and we'll go over that later on properly. But thank you very much for watching. My name's Ben, and this has been a video on soldering. And if you like the video, please give us a like, consider subscribing, and leave us a comment if you'd like to know more. We'll catch you in the next one.